All right, you're tasked with finding the KSP for lead iodate, assuming that the molar solubility of the salt itself is 4.0 times 10 to the minus 5 moles per liter. And so it helps to begin by setting up an equilibrium equation between the lead iodide, which is a solid, and its ions, which will be lead 2 plus and 2 iodate anions. Okay, the 2 is really important here because the concentration of this guy is 4 times 10 to the minus 5 molar. The lead 2 plus and the salt are in a 1-to-1 ratio, so when I put those in solution, I bet I come up with 4.0 times 10 to the minus 5 molar Pb2 plus ions in solution. But I have to remember that I have double that because I have this 2 moles of the iodide anion in solution. Again, this is in a 1-to-1 ratio. This is in a 2-to-1 ratio. So I end up with twice as many iodate anions as I do lead. Now I have this. I have my concentrations. I didn't set up an ice table, but that's okay. I can set up a KSP expression anyway, and I can say that I have lead 2 plus, and I have iodate, and I have to square it. I have to square it because of the 2 right there. Now I don't know the KSP. I do know the concentration of lead ion in solution though. And I do know the concentration of the iodate anion in solution. I just have to remember that I need to square that part. Yes, you took the 2 into account when you multiply the 4.0 times 10 to the minus 5 by 2, but that mathematical operation is separate from the mathematical operation for the KSP. So we want to make sure that we do both when it is necessary. And I come up with a value of 2.56 times 10 to the minus 13 for the KSP. Now that's a very insoluble salt, and lots of lead compounds are also very insoluble. So that looks like an okay answer to me.